Righto. Now, on Friday, we did some questions from a different textbook, New Senior Mathematics, a 3-unit course for years 11 and 12 by J.B. Fitzpatrick. Now, we did exercise 23a, and there were some interesting questions in there, but I'd like to have a go at question 25 because this is a question that some students asked about. So we'll have a look at it, and the equation, or inequation, is 1 over 5x squared minus 2x minus 7 is less than 5 on 13. Now, as you know, when we solve these inequalities, we have a variety of methods that we could use. We could take the reciprocal, which would also mean that we'd have to look at the denominator and when it's equal to 0, because if we just take the reciprocal, we'll get a quadratic, and there's more than two solutions for this, or two regions for this inequality. We could just find all the critical points and solve for the critical points and test all the critical points and find the region. But that doesn't show a deep understanding of what we're trying to do here. The best way, or the way that shows the deepest understanding, is to multiply by the square of the denominator. However, this is going to present us with some problems because it's going to have some pretty difficult algebra to do throughout. But let's have a look at what would happen. Let's say we multiplied both sides of the denominator, both sides of the inequality, by the denominator squared. Now, if we did this, on this side, the denominator would cancel and we'd be left with 5x squared minus 2x minus 7 is less than 5 on 13, 5x squared minus 2x minus 7 squared. So this is a very difficult algebraic inequality to solve. And I'm thinking, all right, so we'll try and go back and do the critical points method. But what I can do here is get an idea, because to show my understanding, or to try and get a better understanding of what we're doing, I can think about what would happen if I did. Now, I don't have to expand the whole thing. I can just look at the leading term. What would happen to that leading term if I expanded this whole expression and then multiplied by 5 on 13? Well, that leading term would become 25x to the 4. And I get all these other things along here. And I'd have 5 on 13 times that. And over here, I've still got my 5x squared minus 2x minus 7. Now, all I'm concerned with is this leading term, because it's just going to give me a quartic. It doesn't matter when I pull these things across, because they won't affect the leading term. The leading term, when I pull all those things across, will be 5 on 13, 25x to the 4, blah, blah, blah. A whole lot of other different parts of the polynomial. And I'm lucky because I know that that's a quartic, and it's a positive quartic, because the number in front of x to the 4 is positive. Now, a positive quartic can look like this. It could look like this. It could look like this, which means it could have a number of possible roots. It could have one root. It could have, it could have 4 roots. Okay, so it could have 4 roots. It could have 2 roots. It could have no roots. It could even have 3 roots because it could go like that and have 3 roots. But I know it's a positive quartic. So now when I find the critical points, I'll have a better understanding of what I'm doing. So let's go back and do the critical points method. So we'll rewrite it again. 1 on 5x squared minus 2x minus 7 is less than 5 on 13. Excuse me. So the first thing we do is we know that 5x squared minus 2x minus 7 cannot equal 0. So that's going to give us some critical points. So we'll solve that. 5x squared minus 2x minus 7 equal to 0. We'll find out where these are. And we use our P and F method. And we're looking for a number that multiplies out to minus 35 and adds up to 2. And that's pretty easy. 5x minus 7x. Sorry, I don't need that parentheses yet. Plus 5x minus 2 equals 0. Haven't changed the equation. Group in pairs, so we'll pull, and that's a squared. We'll pull x outside of that, and we'll get 5x minus 7. And that should be, that should have been a 7. 5x minus 7 plus 1 outside of 5x minus 7. And then I get x plus 1 and 5x minus 7 equals 0. So x plus 1 equals 0, x equals minus 1 is one of these critical points, and 5x minus 7 equals 0. So that means 5x equals 7, x equals 1 2/5. So we've got 2 critical points. And we'll go back over here to this equation, and now we'll solve it. So we'll multiply by 5x minus 2x minus 7 on both sides. And over here, that'll just cancel, so I'll be left with 1. And over here, I'll have 5 on 13, 5x minus, squared, minus 2x minus 7. Now I don't want to deal with that fraction, so I'll multiply the 13 across, and I get 5x squared minus 2x minus 7, or 5 outside of that, which gives me 13. Oh, and I'm doing the critical points method, so I'm not doing an inequality, I'm doing equal to. And that equals 25x squared minus 10x minus 35. Now I'll pull that 13 over, and I'll get 0 equals 25x squared minus 10x minus 48. And now to solve this, I want something that multiplies out to 25 times 48, and that's minus 1200. And I know that that will be 25x squared minus 40x plus 30x minus 48. And that'll give me, now I'll take 5x out of this, and I'll get 5x minus 8. Then I'll take 6 out of this, and I'll get 5x minus 8. And that'll give me 5x plus 6, 5x minus 8. And I'll solve those, so 5x plus 6 equals 0, 5x equals negative 6, x equals negative 1 and a fifth, and 5x minus 8 equals 0, 5x equals 8, therefore x equals 1 and 3 fifths. So I've got my critical points. So let's draw them up. So here I've got negative 1 and a fifth. And I've got negative 1. And over here I've got 1 and 2 fifths and 1 and 3 fifths. So they're my critical points, which means now I've just got to test the regions. But earlier on I showed that I was a bit smarter than just doing simple critical points. And I knew that this was a positive quartic. Well, up here I'm going to get a positive quartic, and I want the part greater than 0. So if I go down now, and I know that this positive quartic will have 4 roots, so it'll look like that. And remember, I want the part above. Right? I'll look back at this quartic. Here it is, up here, and I want the part above 0. So go back to where we were. That means I'm going to want that part below. I'm not going to want this part that's below it. I'm going to want between here and here. And I'm going to want this part and down here. And I'm not going to want to put that part because that's below. But I am doing the critical point method. So even though I'm pretty sure they're going to be the regions, I better check them. So I'm going to let x equal minus 2. And I sub that into the equation. And remember, the original equation was 1 on 5x squared minus 2x minus 7 is less than 5 on 13. So if I let x equal negative 2, and I'll put that in, I'll get 1 on 5 times negative 2 squared minus 2 times negative 2 minus 7. And that equals 1 on 17. And 1 on 17 is less than 5 on 13. So that's part of it. Let's let x equal somewhere between those two. Now, negative 1 and 1/5 is negative 1.2. So I'm going to let x equal negative 1.1. And if I put that in, I get 1 on 5 times, and again, put the negative 1.1 in parentheses, squared, minus 2 times negative 1.1 minus 7. And that equals 4/5. And 4/5 is not less than 5 on 13. So that's a no-go area. Now I'm going to let x equal a number in here, and I'm happy because I can pick 0. So I get 1 on 0 minus 0 minus 7, which equals negative 1/7. And negative 1/7 is less than 5 on 13, so we want that part. 2 to go. So this is 1.4 and this is 1.6. So to test this area in here, I'm going to go, that's x is 1.5. So 1 on 5 times 1.5 squared minus 2 times 1.5 minus 7, and that equals 4 on 5. And 4 on 5 is not less than 5 on 13. So we don't want that area also. Finally, we'll try this last point, and we'll choose x equals 2. So we get 1 on 5 times 2 squared minus 2 times 2 minus 7. And I get 1 on 9. And 1 on 9 is less than 5 on 13. So we want that area. So we were correct. Our understanding showed that we were correct. And we're going to write up what we need. And we need the values of x such that x is less than -1 and a fifth. Then we want also between -1 and 1, between -1 and 1 and 2/5, we want that middle area. We don't need the next one, but we need all the values x greater than 1 and 3/5. And so we now realise we've graphed this inequality, ends up being a positive quartic. We want the region above 0. When I sketch it, that's what we're going to get. So the parts where it's above 0, this quartic, are less than -1.5, between -1 and 1 and 2/5. Sorry, less than -1 and 1/5, between -1 and 1 and 2/5, and anywhere greater than 1 and 3/5. And we're very happy with ourselves because we've used critical points, but we've shown with a hybrid of techniques that we have a deeper understanding of what this question is asking. And we checked with Bob, and Bob says, yes, you are indeed correct. So well done.